All right, what are you guys thinking? Anybody have any good ideas? They don't even have to be good ideas. Any ideas at all? No right or wrong answers. Just what you notice about the relationship between those two. What'd you see, Nathan?
It's got a y and then x right after. Like
Great. They both have x's and y's because they're what type of functions? No, a parent function would just be y equals x. If it's just x, is that y equals? Think about m
and
x plus
slope,
b.
yeah,
That's what type of function?
linear.
Linear.
Yeah.
Yes, that's slope. Good. All those words. Yes, Jaden.
They look like opposites.
Okay, good. I like this word Jaden's throwing out there. They look like opposites. Tell me more. What do you see?
Like there's a -5 and then the other one is a +5, and then one is multiplied by 2 and the other one is divided by 2.
Yeah, good. Those are opposites. What else do you see, Chloe?
So I tried to think of the first one in like a y equals mx plus b format.
Uh-huh.
So I did like y equals 1/2 x plus 2.5 or 5 halves.
Yeah.
Yeah. So it was easier to compare, and you could see that. It just kind of further points out that they're opposites, sort of.
Yeah, good. So I like that I keep hearing this word opposites. That's our topic for today. But in math, we don't just say, hey, these two functions are opposites. What is the math word that we're going to use when you are talking about opposite? What do you remember, Malcolm? Inverse. Good. Remember addition and subtraction. Inverses. Multiplication, division. Inverses. So that's our topic for today. It is about inverses. So what's the meaning of an inverse function? Exactly what you guys said. Opposites. So kind of think about if I have addition, my inverse is going to be subtraction. If you have multiplication, your inverse is going to be division. Anybody have an idea how you can determine if things are inverse graphically? Let's look at these graphs. Maybe it'll spark an idea.
Isn't it like kind of like skipping like it's like on the graph it's just like pausing and then like it's like ending after.
Wait a minute.
You just go.
What happened to the music?
What?
So they don't do, oh my gosh, they don't do it during lunch. Have you just noticed that?
Yes.
No, they haven't been playing it for like the past
Really?
Yeah.
No, they played it yesterday.
Yeah.
No, they played it yesterday.
Okay. All right. Look at our graphs. And so we already talked about how these two are inverses. What do you notice graphically? Like, these are inverses. What's maybe you're noticing something they're doing? What do you see, Thomas?
They intersect in a point where the y and x values are the same.
Love that. They intersect where your x and your y values are the same. This case here, 5, 5. What else do you guys see? What do you see, Lucas?
It looks like it like reflects over like a line, kind of like
Yeah.
the y equals x line.
Boom. Lucas hit it on the money. Y equals x. Oh, let's change the color so we notice it more.
You have to click this.
Yeah. Green, yes. So looking here, y equals x. That line, Lucas, was like, it looks like it reflects over a line. Though, you know, that one that goes down the middle, y equals x. Good. Thomas kind of started it off knowing that 0.55 was shared. So x equals y, meaning when the x and y values are the same, they're going to share. So let's find another good point on this red. So we have the point here, 1, 3. Now let's notice some things about blue. Maybe. All right, what are you guys kind of noticing? Specifically, we can kind of zone in on the point red 1, 3. Red has 1, 3. What are you noticing that blue has? What do you see, Yusra?
1, -3.
Yes. That's good. That's good. What else do you see, Thomas?
I was thinking of 3-1.
Yes, 3, 1. That was the unintentional but good thing to notice, Yusra, with it being negative. So, in order to be an inverse, graphically, you're going to reflect over y equals x, and your x and y values are going to be flipped, opposite, swapped of each other. So, back up here. Our inverses need to be opposite. Graphically, it'll reflect over y equals x. And additionally, your x and y will be switched. Meaning, if my function has the point, so f of x is your original function. If you have the point 1, 3, like our graph just did, your inverse. So to be an inverse, we use the following notation. F, an exponent of -1 of x. So that says the f inverse of x. That would have the point 3, 1. So when you see that notation moving forward with the -1 exponent, that means an inverse. And those points are just swapped. Yes. So how do we find a function's inverse algebraically? Well, let's think. What was our whole idea? And that we just talked about. Your x and y will be flipped or switched of each other. So that's going to be step 1. So finding it algebraically. You're going to switch or swap x and y. So think about if I'm swapping x and y, and something like y equals 2x minus 5 would become x equals 2y minus 5. And now you want to get it in that y equals mx plus b form, which means you'll have to solve for what variable? Y. So then you're going to solve for y. So you'll switch x and y and solve for y. That's the big idea for today. Do you remember ideas of inverses maybe from Algebra 1? Maybe.
What?
What? You remember inverses from Algebra 1?
Inverses?
Yeah.
No.
No? Kind of, maybe, the word. So, I'll give you guys a couple more seconds to jot down any ideas. First up, looking at a graph, we want to sketch the graph of, what does this -1 exponent mean again?
Switch. Inverse.
The inverse. So this says, hey, graph the inverse of my f of x function. That's what you're given. You're given this graph, which is f of x. How could I figure out what the inverse would be? What do you remember, Jaden?
By doing like the reverse of the x and y.
Yeah, so let's think.
Reverse.
You're off to a good idea. Here on f of x, I have the point 1, 0. So what point will my inverse have? 0, 1. So I know so this is saying the inverse of f of x function so my f inverse of x would have the points 0, 1. So let's plot 0, 1. What else do we see? I'm only going to get at least 3 good points, so I got 1 down. How can I figure out another one, Eve?
0, -4.
How do you know 0, -4?
What?
So,
I was
0,
saying 0, -4 was a point that we could,
swap around?
yeah, we could swap it around to be -4, 0.
Great job. We'll swap it around, and now we'll make -4, 0. All right, one more. Let's find another one. What do you see, Malcolm?
2, 1.
2, 1. That's a good point on my function f of x.
1,
So
2.
there you go. Took the words out of my mouth. The point 1, 2 will be on our inverse. Now I have 3 good points, so that looks good enough to me. And graphically, how can I kind of confirm, or like, what should I also be noticing?
It looks like
How does it look like it? What should it be doing?
curving.
Tell me more. Not just only curving. Reflecting over what? Yeah, so if you draw that line y equals x, boom, 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 I should be reflecting off of it. Now, look. Does it look like I'm reflecting off of it?
Yeah.
Yeah.
But like, what if it's like in a weird spot? Where it can't do that?
What do you mean?
It's like, oh wait, yeah, you could probably do it no matter what. I just realized. Never mind.
And if you come across a scenario where if not, we can look at it and maybe determine why. Some functions you're not going to be able to totally find an inverse. Just, you'll kind of see as we move throughout the year. Some of the graphs get kind of wild and crazy. What other questions do you guys have? All right, we're going to look at some problems algebraically now. So why don't you guys take a minute and jot down these 2 examples, and then we'll run through them together. All right, so we're going to find them algebraically. Chloe was just reminding us. What's our first step? What was it again, Chloe?
Switch x and y.
Switch x and y, but I don't see y here. What's the same as y?
F of x.
Yeah, so I know y is the same as f of x, so that means I'm going to swap. So x will equal 3y minus 1. Now I want to solve for y. How would I do that? What would I need to do first?
Add 1.
Great.
Add 1 plus 2.
Add 1 and then divide by 3. So I like that you're saying add 1, divide by 3. Remember just to take it one step at a time, because that's what I noticed first period was trying to do 2 steps at once. And they, just slow and steady wins the race. So now we'll divide by 3. And when you get to this point here, notice you'll have your y by itself. And when you have your y by itself, kind of noticing on your left, you'll have just x plus 1 all over 3. You could also express it as x over 3 plus 1/3, as long as you're just, saying it mathematically correct. But notice I wanted to find the inverse. I started off with f of x. So really my notation should be what here?
F of x equals x plus 1 over 3.
Almost, not quite f of x, because that's the original function. I want to say it's the inverse. What do I need to show? Yeah, f negative 1 of x. And now just do a quick visual check, right? What did my original problem have? A minus 1. What does my inverse have?
Oh, plus 1.
Cool. I have a multiplying by 3. What does my inverse have?
Dividing.
Divide by 3. Great. So next up we have g of x equals 1/4 x minus 1. What is my y? G of x. We don't have a little... So I know it should be x equals 1/4 y minus 1. And next up we want to solve for y. What are some ideas you guys have to help us solve for y?
Multiply 1/4 on each side.
Almost.
times 4.
I don't want to multiply by 4 because think about it, I want to get rid of this. So multiplying it by 3. So multiplying by 4 over 1 or just 4 on both sides would help me clear that fraction. So we'll end up with 4x is equal to now just y minus 1. I think I heard Olivia whispering you could distribute. And yes, you could also distribute first. If you want to do that, that might just have you deal with fractions for a step or two. Now just to get y by itself, one more idea, which would be to do what? Add 1 to both sides. So we'll end up with y is going to equal 4x plus 1. But instead of y, we want to express it as the inverse of g. So g inverse of x.
G.
It's g. Letters, you know. What questions do you guys have here? All right, I'm going to give you guys 2 to practice on your own. We'll just kind of check our answers together, and then you guys will have the rest of the time to work.
That's the